to starry cosmos. For untold millennia, the moon has hung in our night sky, a silent, luminous guardian. It has been a constant companion, an object of myth, and a beacon of wonder, yet always just beyond our grasp. We have gazed upon its mottled face, dreamed of its barren plains, and even briefly set foot upon its dust. But what if our ambitions stretched further than mere visits? What if we dared to dream of permanence, of truly living and working on that alien surface? Imagine constructing a new civilization, a sustainable outpost under its unfamiliar light. This is no longer the realm of pure science fiction, for humanity is now reaching for a lunar future, preparing to build a home among the stars. Dim your lights, settle in, get comfortable, and let us begin. If these quiet journeys help you drift off, hit that like button and subscribe to Starry Cosmos so that the next journey through the vast expanse finds you when you need it. For countless generations, humanity has gazed upon the night sky, finding a constant companion in the moon. Its gentle glow has illuminated our darkest nights and guided ancient travelers across the land. This silent sentinel has always held a profound place in our collective imagination. It has inspired poets, artists, and dreamers throughout history, weaving itself into the very fabric of our myths. Beyond legend, a deeper aspiration before our current aspirations, humanity already gazed at the moon with an ambition that reshaped our understanding of the cosmos. The Apollo program, born from a profound challenge, set out to achieve the seemingly impossible. Its primary objective was to safely land human beings on the lunar surface and then return them home again. This monumental effort pushed the very boundaries of engineering, science, and human endurance itself. It sought to, after humanity's initial journeys to the moon, the next great challenge lies in establishing a permanent presence there. Before we can build, however, we must first truly understand the formidable environment that awaits us. The lunar surface, though seemingly serene from a distance, presents a gauntlet of extreme conditions for any prospective inhabitants. Each factor demands careful consideration and innovative engineering solutions. The first and most pervasive challenge is the absolute vacuum of space itself. With virtually no atmosphere, there is no air to breathe, nor any pressure to contain liquids. This means that unprotected human bodies would instantly expand, and exposed water would boil away into the void. Equipment must be designed to function without the benefit of atmospheric cooling or insulation. Beyond the vacuum, an invisible but deadly threat permeates the lunar landscape. Without a thick atmosphere or a protective global magnetic field, you are directly exposed to the sun's fury. Harmful solar radiation streams unimpeded across the surface, especially during powerful solar flares. These energetic particles can damage human cells and delicate electronics alike. Even more insidious are the galactic cosmic rays, which originate from distant supernova. These high-energy particles are a constant presence, demanding robust shielding for any long-term habitat. The moon's surface is also constantly bombarded by countless tiny fragments of space debris. These micrometeoroids, often no larger than grains of sand, strike with incredible velocity. Over time, these impacts can erode surfaces, pit exposed equipment, and pose a threat to pressurized habitats. Even small punctures can lead to catastrophic depressurization. With no atmosphere to trap heat or distribute it evenly, lunar temperatures swing wildly. During the day, the sun-baked surface can reach a scorching 120 degrees Celsius. Conversely, during the long lunar night, temperatures plummet to an astonishing minus 170 degrees Celsius. Such extreme shifts require sophisticated thermal management systems for both structures and vital equipment. Perhaps one of the most unexpected challenges is the lunar dust itself. Unlike earthly dust, it has not been weathered by wind or water into smooth particles. Instead, Lunar Regolith consists of jagged, abrasive shards, akin to tiny pieces of glass. This dust clings to everything, infiltrating seals and abrading machinery. It can cause respiratory problems for astronauts and short-circuit sensitive electronics. Managing this pervasive contaminant is crucial for maintaining a healthy and functional base. This lack of both a substantial atmosphere and a global magnetic field underpins many of these dangers. It leaves the moon utterly exposed to the harsh realities of space. These conditions define the very nature of lunar, though the lunar environment presents an undeniable gauntlet. Humanity now stands poised for a new chapter of exploration. Decades after the triumphant Apollo missions, we are returning with a renewed purpose and an extraordinary vision. The Artemis Program represents a profound shift in our approach to lunar travel. Its central aim is not merely to visit the moon once more, but to establish a sustained human presence. You can imagine a future where astronauts live and work on the lunar surface for extended periods, perhaps for weeks or even months at a time. This ambitious endeavor is truly a global undertaking. Nations from across the world are contributing their unique expertise and resources to this shared vision. Organizations like the European Space Agency, the Japan Aerospace Exploration Agency, and the Canadian Space Agency are integral partners. They are providing vital hardware, scientific instruments, and human support for this grand return. This differs significantly from the pioneering efforts of Apollo. Those historic missions were focused on proving humanity's capability to reach the moon and return safely. They were brilliant, daring expeditions that left flags and footprints as monumental symbols of achievement. However, they were relatively brief visits, lasting only a few days on the lunar surface. Artemis, by contrast, seeks to build a lasting foothold. It aims to develop the infrastructure necessary for a permanent outpost, laying the groundwork for a true lunar habitat. This means developing sophisticated life support systems, creating robust power sources, and even learning how to extract resources from the lunar soil itself. You are witnessing the beginning of a sustained human presence beyond Earth. The moon will serve as an invaluable proving ground for humanity's future in deep space. Here, astronauts will master the technologies and operational protocols essential for even longer journeys. Imagine the challenges of operating a habitat far from Earth, where supplies are scarce and communication delays are significant. The experiences gained on the moon will be directly applicable to missions to Mars and beyond. We will learn how to protect crews from the harsh radiation environment, and how to manage the psychological aspects of long-duration spaceflight. The lunar surface offers a unique laboratory for testing propulsion systems, advanced robotics, and self-sustaining ecosystems. Every lesson learned on the moon will bring us closer to becoming an interplanetary species. This journey is not just about revisiting a familiar celestial neighbor. It is about preparing for the vast, unknown expanses of the solar system. Our journey to the moon requires a specialized vehicle, one capable of carrying humans safely beyond Earth's protective embrace. This is the Orion spacecraft, a marvel of modern engineering designed for deep space exploration. It consists of a crew module where astronauts live and work, and a service module. The crew module resembles the Apollo capsules, yet it is significantly larger. It provides more space for longer missions and to leave the embrace of Earth and journey to the moon. You need a force truly immense. This is the realm of the Space Launch System, or SLS. It stands as NASA's most powerful rocket ever conceived. The SLS is a monumental feat of engineering. It is designed specifically to carry humans and heavy cargo deep into space. At its core, the SLS features a colossal central stage. This stage is powered by 4 powerful RS-25 engines. These are the same engine type that once propelled the space shuttle. Flanking this core stage are 2 immense solid rocket boosters. Each booster provides tremendous thrust at liftoff. They deliver over 75% of the total power during the first 2 minutes of flight. Above the core is the interim cryogenic propulsion stage, or ICPS. This upper stage provides the final push. It sends Orion on its journey towards the moon. The assembly process for such a giant is a spectacle in itself. It takes place within the iconic Vehicle Assembly Building. This is at the Kennedy Space Center in Florida. Here, individual segments of the rocket are carefully stacked. Each piece is meticulously integrated. Imagine components arriving by barge and truck. They are then slowly hoisted into position. Eventually, the entire rocket stands upright. It towers over 300 feet tall. This incredible structure awaits its moment of truth. The fully assembled rocket, with Orion atop, is then rolled out. It moves slowly to launch pad 39B. This journey itself is a monumental undertaking. When you witness an SLS launch, you are seeing history reignited. Its power evokes memories of the mighty Saturn V rocket. The Saturn V once carried Apollo astronauts to the moon. The SLS builds upon that legacy. It surpasses it in certain capabilities. It is designed to lift heavier payloads than any rocket before it. This includes not just the Orion spacecraft. It can also carry future habitat modules. These modules are essential for building a lunar outpost. The sheer scale of the SLS at launch is breathtaking. It generates over 8.8 million pounds of thrust. This incredible force lifts the massive vehicle skyward. You feel the ground vibrate with its power. The exhaust plume illuminates the night sky. It turns darkness into an artificial dawn. This is the raw power required to break free. It provides the momentum to send you beyond Earth orbit. It sets you on a course for another world. This magnificent rocket makes our lunar aspirations a tangible reality. It is the Titan that will carry humanity back to the moon beyond the powerful launch of the Space Launch System. Our return to the moon entails more than just direct trips to the lunar surface. Unlike the Apollo era, a new permanent presence will orbit our celestial neighbor. This ambitious new element is known as Gateway. It is a small, modular space station designed to circle the moon, serving as a critical waypoint for future lunar exploration. Gateway will not simply from the silent vigil of the gateway. Your next grand step brings you even closer to the moon's ancient face. It is from this orbital outpost that you will prepare to descend, leaving the comfortable confines of the station for the challenging journey to the lunar surface. This critical leg of the Artemis missions relies upon a new generation of spacecraft known as human landing systems. These remarkable vehicles are designed to our vision for a sustainable lunar future hinges on a remarkable discovery. For decades, the moon was thought to be a dry, airless world, devoid of liquid and atmosphere. Then groundbreaking missions like Chandrayaan-1 and L-Cross confirmed a profound truth. Significant quantities of water ice lie hidden within its polar regions. This revelation utterly transformed our understanding of lunar potential. It also defined a clear target for establishing humanity's first permanent foothold on the moon presents many profound challenges. Among the most immediate is the creation of safe and habitable shelters. These initial structures must protect explorers from the harsh lunar environment. They provide sanctuary against the vacuum and relentless radiation. Concepts for these early habitats often involve ingenious designs. Inflatable modules, for instance, can be launched compactly from Earth. Once on the lunar surface, they, while constructing those first foundational shelters, provides a critical foothold. A sustainable human future on the moon demands something more profound. It requires us to transform the lunar environment itself into a source of life and sustenance. This essential principle is called In-Situ Resource Utilization, or ISRU. It means living off the land, using what is already there, rather than relying solely on costly supplies from Earth. Perhaps the most valuable resource locked within the Lunar Regolith is water ice. Scientists believe vast reservoirs of this precious commodity lie hidden within permanently shadowed craters near the moon's poles. Robotic probes can extract this ice by heating the lunar soil. The resulting water vapor is then collected and purified. This water becomes vital for many purposes. You could drink it, of course, after careful processing. It also becomes the foundation for producing breathable oxygen. Electrolysis, a simple chemical process, splits water molecules into hydrogen and oxygen. This oxygen could fill habitats, sustaining the very air you breathe. Beyond breathing, oxygen also serves as a crucial component for rocket propellant. Combined with hydrogen, also derived from water, it forms an efficient fuel. This means future missions launched from the moon could refuel directly on its surface. Imagine the possibilities of spacecraft departing from a lunar base, fueled by lunar resources, embarking on journeys deeper into the solar system. Lunar soil itself, known as regolith, offers incredible potential as a building material. This gritty, abrasive powder covers the entire lunar surface. While challenging to work within its raw form, it can be processed and used for construction. Techniques like 3D printing are especially promising. Robots could melt and bind regolith particles, layer by layer, to create durable structures. These might include protective walls for habitats, landing pads, or even entirely new buildings. Such structures would provide vital shielding from harmful cosmic radiation and micrometeoroid impacts. You could build robust and resilient shelters directly from the ground beneath your feet. This ability to manufacture fuel and building materials directly on the moon dramatically reduces our dependence on Earth. Each kilogram of water, oxygen, or regolith-derived building material we create locally saves us from launching that same mass from Earth's gravity well. This makes lunar exploration and settlement far more economical and efficient. It transforms our presence from a series of fleeting visits into a permanent and evolving human outpost. Learning to live off the land is not just a technological challenge. It is the path to truly becoming a multi-world species. Our lunar future hinges on mastering these essential skills, with initial resources now being gathered from the lunar surface itself. The ambition to build something truly lasting begins to take hold. This next phase involves expanding the outpost far beyond its first modest shelters. Engineers are developing advanced construction techniques tailored specifically for the harsh lunar environment. Imagine robotic builders guided by intricate designs, utilizing the moon's own dusty regolith as a primary building material. Massive 3D printers, once a permanent lunar presence is established, a new rhythm of life will slowly unfold. Each lunar day would bring a unique blend of purpose and quiet routine within your habitat. Your mornings might begin with a careful check of the base's vital systems, monitoring air quality, power levels, and water recycling remains a paramount, ongoing task. Scientific research would then occupy a significant portion of your carefully scheduled yet a sustained human presence on the moon extends far beyond the daily routines we might establish there. lunar base provides an invaluable testing ground for the much longer journey to Mars. Every system, from life support to advanced propulsion, can be rigorously evaluated here. You can refine habitat designs under real lunar radiation and vacuum conditions. This approach allows us to perfect the tools needed for much longer interplanetary voyages. The idea of humanity becoming a multi-world species is no longer just a distant dream. It is a horizon we are actively approaching with each passing mission. Our journey to the moon represents far more than a simple scientific endeavor. It is a profound declaration of our capabilities and our innate drive to reach beyond. We are not merely visiting, we are learning to live there. This ambition transforms our understanding. We have journeyed to the moon, envisioned its future habitats, and glimpsed the intricate blueprints of our next steps among the stars. This distant, silent companion, once only a luminous beacon in our night sky, now stands as a profound testament to humanity's enduring dreams. Each lunar step we plan, each structure we design, extends our reach, reminding us of our small place, yet boundless potential in the vast cosmos. Thank you for spending this time among the stars with me. If you enjoyed the journey, a gentle like and a subscribe help more quiet dreamers find their way here. Until next time, rest well and keep wondering about the cosmos. Good night.